is my breadboard setup for validating the new design for the MegaIC Tester circuit board. Up the top here we've got the 74HC 4067 16 channel analog multiplexer. Up at the other end here we've got the 4066 quad switch. In the middle there on the little circuit board we've got a 205 ohm 0.1% resistor, then we've got a PTC fuse in the middle, and at the other end we've got a 225 ohm resistor. Down here we've got the 5V voltage reference standard, and here I've got a little resistor divider network made with three 205 ohm resistors in a ladder, so that I can actually divide the 5 volts that comes out of the voltage reference, and then using the high accuracy resistors I then get 5 volts, 3.3 volts and 3.3333 volts and 1.6666 volts. Okay, so I've got this hooked up to an Arduino Mega, and it is the circuit is configured in the same way as the design. So the Mega, using these digital I/O pins over here, is switching the analog switch here, and it is therefore measuring the voltage across the 205 ohm resistor on the little circuit board there. I've got a circuit that goes through the resistor, the 4067, the PTC fuse, and this potentiometer, which means I can then vary the current that goes through the resistor, and then using the 4067 and the Arduino we then measure the voltage across the resistor, and we can then work out the current. So that's the breadboard setup. Over here we've got my HP mixed signal oscilloscope, right? So this is showing here that these are the reads. I've actually got 4 voltages set up, one across the circuit that's got the potentiometer in it, and 2 that are across 2 of the precision resistors in the ladder network, relay ladder network on the precision voltage reference. The precision voltage reference is being driven by this, so I'm putting 5.69 volts into it, and looking down here, turn the multimeter on, wait for it to settle. There you go, there's the 5V reference, exactly 5 volts. And then over here, this is the voltage across the resistor, so that's currently at 1.8 volts. Now up here on the screen, we've got the voltage that's being measured across the resistor by the Arduino, and it's reading 1.85 volts, so it's very close to that. And from that it's working out that we've got a current flow of 890 microamps, and at the other end we've got a voltage of 1.6 volts, and that's the voltage across the bottom of the 205 ohm resistors in the relay ladder network. So if I now tweak the potentiometer, so we're now down to 504 millivolts across the resistor, and the Arduino's measuring 502 millivolts. So and from that it's determining that we've got a current flow through the resistor of 2.45 something or other microamps. Now, even though I've got the voltage reference in the circuit down here, I'm not actually using it to calibrate the readings on the Arduino's analog to digital converter, but if I did, then I could get those readings even more accurate. So just give it one more tweak, sort of like down to its lowest current reading. Okay, so we've now got 54 millivolts across the resistor, and here we go, we've got 53 millivolts being measured, which equates to 260 microamps. And if we go up to the top end of the range, so there you go, we've got 3.97 volts across the resistor now, and that's being read by the Arduino as 3.95, which equates to about 20 milliamps. So this has allowed us to validate the design of the circuit for the MegaIC tester. Now if I just change the resistance down so that we got to a fairly low current level, so there's 101 millivolts across the resistor. I've also got a switch down here which is connected to the 4066, which is the analog switch that's actually across the resistor. And if I change that, if you watch here, then at the moment we've got 101 millivolts across the resistor, switch it, and it goes down to 15.9. So that's due to the fact that the 4066 analog switch still has some resistance. It's not like a large copper switch like that. It's only just done with silicon, so there is still some resistance even though we've taken the resistor out of the circuit. So that's showing that the circuit appears to be valid. And if we actually go and have a look at the oscilloscope over here, here's where we're doing 4 readings, one on each side of one of the resistors, and then one on each side of one of the other resistors. One on each side of one of the resistors in the relay ladder, in the resistor ladder network. So up here we've got the actual voltages that are being measured on the common output of the analog switch. So if I tweak the voltage, you can see that the voltage changes, but only in certain parts of the waveform as the signal is being multiplexed into the Arduino to be read by the analog to digital converter. So good news, the circuit design looks to be good. I might add the calibration in using the precision voltage reference, but at the moment it looks like I'm good to go.